Okay, we're going to go over a few situations where we can use the binomial distribution to solve problems. So our first problem here says you take a test of 10 multiple choice questions, each with 4 possible answers. You absolutely have no clue about any of the answers, so you guess randomly on each question. Okay, so part A says, how does this describe a binomial distribution? So the number of trials would be the number of questions on the test. So our n is 10. That's our fixed number of trials. We'll define success here as getting the question right. So guessing the question right. Now our trials are independent here because how you do on the first question on a multiple choice test doesn't affect how you do on the second question. We either get it right or you get it wrong. So those are our two possibilities. And then your probability of guessing the question right each time would be 1 out of 4, or 0.25. Your probability of failure of getting it wrong would be 3 out of 4, or 0.75. Now our random variable x here will represent how many questions you get right on the test. So part B says, what is the probability that you get exactly 5 of the 10 questions correct? So we're going to do on our calculator binom PDF. So remember, we put our n first. So 10 questions. Our probability of getting a question right, 0.25. And here we want to know exactly 5. So trials was 10. The probability is 0.25, and we want to know for 5. So here we get 0.0584. So you'd have just about a 5.8% chance of getting it 5 right. So getting 3 of them right, we're going to do binom PDF. Still 10 questions. Your probability of getting it right is 0.25. And now our x is 3. The only thing we have to change here is our x value. Oh, somehow I got an extra period in there. Okay. So here, 0.2503. So about a 25% chance that you'd get 3 of them right. D says, what's the probability that you'll get at least 1 right? So remember, at least 1 is the complement of none. So we're going to do 1 minus the probability of 0. So 1 minus, we can actually do 1 minus in our calculator before we go to the distribution. Okay, and we're just going to change our x value to 0. And that will paste that in there. And we see that our probability of getting at least 1 right is 0.9437. So about a 94% chance that you'd get at least 1 question right if you were guessing. Okay, we're going to look at one more situation. So this says the Medis pharmaceutical company is testing a large 1,000 batch of aspirin tablets. They randomly choose 25 tablets. If all of the 25 tablets are good, the entire batch is accepted. If any one of the 25 tested is defective, then the entire batch of 100 is rejected. So we're going to treat it as independent. So unknown to them, 100 of the 1,000 tablets are defective. Okay, so first we want to figure out, is this binomial? So our fixed number of trials is how many tablets we're choosing. So that's 25. We're going to define success as a tablet being good. Being not defective. The random variable x represents how many out of the 25. So how many are good out of the 25 that are sampled? Success for any one trial would be P of 1. So we'll do second distribution, the binomial PDF. So our number of trials, we're picking 25. Now our probability of success, we know that 100 of them are defective, which means 900 out of the 1,000 are good. So the probability that what we wanted to put here, the probability of success for any one trial, any tablet, that's what we just put in, 900 out of 1,000. Now, what we're interested in testing, we only care if all 25 are good. So we're going to put in 25. So here we get 0.0718. So there's about a 7% chance that it'll be accepted even though there's 100 bad pills in there. Okay, what is the probability that exactly 3 of the 25 tablets are bad and 22 are good? So here x would be 22. We're going to do the same thing we just did, but put 22 in there. So the only thing we're changing is our x value. So it would be 0.2265. Okay, so there are some situations where we can use the binomial distribution to solve problems and find probabilities.